Okay, which grades do we have here? Okay, do we have any grade 10? Grade 10, because I'm thinking of doing some grade 10 paper 1 stuff. Paper 1 stuff for grade 10s. Oh, there we go, my network. Hi, network. Network never loved. Network never loved. Network never loved. Right, guys. I'm gonna look at some some exam questions. Grade 10 exam question. Just let me know how's the network. How's the network looking for you guys on your side, so that I can see if whether there's something that can be done. Just let me know what's the network situation like on your side. Let's just do this. Alright, so I'm just trying to give some grade 10s some equal time here, guys. So you'll have to excuse me, those who are like, what about our grade? What about our grade? I haven't been doing live sessions in a while, and yeah, grade 10s have been underfed. I have not been doing nothing with them, so I just thought it would be appropriate today to sort of like look at some aspects of paper 1 for grade 10. Now, I know that various people may be doing various things insofar as like what will be covered exam wise, but I just want to cover a little bit of functions with the grade 10s, right? Please, can you guys indicate in the comment section if you can hear me? Am I audible? Is there lagging? Is the network okay? Things like that. If you guys can comment on those things in the comment section so I can know as to what's the situation like. If it needs to change, I have it. If I need to leave because it's not good enough, I can leave because it's not good enough. Let me know in the comment section how's the network, so that I can know how are things. Am I audible? Can you hear me? Is it bad? Is it good? Speak to me, talk to me, comment somewhere. Someone comment in the comment section. I need to know. If I don't know, then I don't know, If I know, I can proceed. If I don't know, I won't. Okay, no one's commenting in the comment section, so that means I'm not audible. People can't hear me. The network's there. Alright, according to my network, the network is fine. Network I currently, it must be your network that's not currently, because good connection. So that means your guys' network is the one that's playing tricks. Okay, mine is fine. Okay, it says good network. Okay. Alright guys, well, let's look at this question here. Looking at functions. We can jump around. We'll look at functions, we'll look at some factorization, functions factorize, functions factorize, addition of algebraic fractions, equations. We'll just jump around some things, okay? So just bear with me, grade 10s. This is a grade 10 session. Alright, so obviously that means there are limitations to the grade 10 aspect of the syllabus. So let's look at this. Draw the graph of f of x is equal to minus 4 into brackets half to the power x plus 4 on the given diagram sheet. Okay, it's just that we don't have a given diagram sheet, but if you were provided one, you would draw the graph on the given diagram sheet. It says label the graph and clearly show. What does it clearly show? Show all intercepts with the intercepts and any asymptotes. Okay, it will be done in conjunction Lerad, so you're going to have to bear with me. Yes, you can't see because I basically you guys kill me. Okay, you should understand that from the perspective of someone who's doing the live session and your guys' comment section, it's quite a it's quite an entertaining scenario that you guys create. All right, you create quite an entertaining scenario. Okay, so here we have a function. All right, so here you have f of x. Now f of x, guys, is, we call this functional notation. All right, this is functional notation, and what it means is it means y. That's what it means. Okay, so f of x is just something that stands for y, right? So y is equal to, as it says, but the thing is they use f of x just so that we can distinguish between functions. All right, so f of x is equal to -4 times half to the power x plus 4. All right, so this is the function that we have. So in other words, the function we are given is y is equal to -4 times a half to the power x plus 4. Right, so this is a function. What kind of function is it? All right, no, baby G, the reason why they put this is because this is a form of notation that you need to know. You need to know this notation, right? Because if, let's say, on a particular Cartesian plane, they decide to draw a straight line, let's say they draw an exponential function as well, you know, all right? Note this. Let's say this exponential function that they've drawn here, all right, they label it as f of x, all right? That's just them being able, this is just a way for them to distinguish between two functions. Okay, so maybe this straight line, all right, will be called g of x. Okay, does that make sense? So obviously the function itself, maybe it will be y f of x is equal to, let's say, the exponential function f of x is equal to 2 to the power x. I'm just making things up here, right? And then here g of x maybe is equal to x plus 1. All right, this is just, like I said, made up. Okay, at the end of the day, g of x means y, f of x means y, h of x, let's say there's a parabola there, let's just say, you see, now I'm just adding a lot of functions onto one system of x's. So h of x, let's say they say h of x is equal to x squared, right? So all of this, g of x, f of x, h of x, what does this all mean? It all means y. Okay, so h of x is a form of notation that they use in functions, and all it means is y. So that means if I rewrite g of x is equal to x plus 1 in terms of y and x, I can say y is equal to x plus 1. This is my straight line function. If I want to rewrite f of x is equal to 2 to the power x, I can say y is equal to 2 to the power x. That is my exponential function. And then y is equal to x squared. So basically h of x is equal to x squared. I can rewrite that as y is equal to x squared. Okay, so all of this, my dear baby G, because baby G was wondering, why didn't they put y? They are making it complicated, right? And yes, baby G, you are 100% correct. They are just making things complicated, but at the same time, these are things that you need to know. Remember, they just, complexity in mathematics, obviously, all right, is just something that is there and that exists. But at the end of the day, remember, these things right? Once you understand them here in this phase of your academic journey, when you go to university and maybe, let's say for instance, you do functions in university, all right, then you will be able to understand the meaning of f of x, h of x, g of x, and so forth. This is a notation that is pretty much used there in that level of education. So you need to understand, at least at this level, g of x, f of x, h of x. This is just, like I said, this is called what? It's called functional notation, all right? But basically, f of x means y, h of x means y, and g of x means y. Okay, so basically all of these, what they mean y. All right, I hope that makes sense. So now if they have here, they say draw the graph of f of x is equal to -4 times half to the power x plus 4. What you need to just understand here is that what they are telling you here is that this function is actually referred to as f of x means y is equal to, then you have -4. That's the -4 there. This dot means multiply, so that's times a half, and then look here, you have a variable of x which is represented as a exponent, so that's to the power x, and then it's followed by what? By +4. Right, so basically this here is what we refer to as an exponential function. So what I'm going to do just quickly, I'm just going to show you, or I'm going to expose you to the forms of the different functions. So we have a linear form or a straight line, what they refer to as a straight line function. So a straight line function, guys, has the following form. A straight line function has the form y is equal to mx plus c. Straight line. Your straight line can either be like that. Straight line can either be like that. Straight line can either be horizontal, or a straight line can either be vertical. Okay. So the form of the function is y is equal to mx plus c. So if you look at the x variable, the exponent of the x is simply the number 1. Okay, so y is equal to mx plus c. That's what we refer to as a straight line function. All right, so this is what we refer to, this form of the function is the linear form. Y is equal to mx plus c. All right, straight line. All right, so that's how you can be able to at least identify a straight line function. Y is equal to mx plus c. Okay, I'll go into the details as to what everything means, but for now, please understand a linear function or a straight line function is in the form y is equal to mx plus c. So as a grade 10 learner, in grade 9 already, you guys were exposed to a linear function or a straight line function. All right, so 2, we have a exponential function. Okay, your exponential function has the form y is equal to ab to the power x plus q. Okay, now you should notice something about your exponential function as opposed to your linear function. Your linear function, your x variable is in line with your coefficient, all right, which is m. All right, and the exponent of that x variable is 1. Your exponential function, on the other hand, has its x variable as an exponent. All right, okay, so that's very important to note. Okay, you have ab to the power x plus q. So we know for a fact that this is an exponential function. It can't be linear, it can't be a straight line. Right, so your exponential function is always either an increasing function like this, or it can be a decreasing function like that, or it can be increasing in that direction, or it can be decreasing in that direction. Now, obviously, when we go into the basics, okay, after going into the basics of this, you will understand why it is that this function is this shape, that shape, that shape, that shape, according to what the value of a, b, or q is. So for now, people, I'm just exposing you to the different types of functions that we do have and the form, okay, and the form that we have. So the linear function, like I said, is always in the form y is equal to mx plus c. All right. Okay. Then exponential function, on the other hand, y is equal to ab to the power x plus q. There's an exponent x. All right. So that's why we say it's an exponential function, because the variable x is an exponent. Okay. Then we have two more additional functions that we learn in grade 10. All right. The other function is what we call the parabola, or the quadratic function, as they usually call it. Quadratic function. Okay, baby G, I see your hand there. What's up? The question is, guys, if you are writing on Friday, right? The question is this section going to be included in your paper one? Okay, is this section going to be included? Have you done functions, and is it also going to be included in your paper one? Okay. All right. Then the next question I want to ask, if you did this, have you covered this topic in school and in class? Have you covered it? Because if you've done it in school, you've covered it, then my question is, am I speaking Greek to you guys as I am writing down the form of these functions? Because if you've covered it, all right, you don't understand it. No, we haven't done the topic. So you haven't done the topic, but you are writing the test on Friday on the topic that you haven't covered. Is that correct? You don't understand. Okay. So that means that, so you guys want to be taught from the beginning. Baby G. Guys, this topic is such a nice topic, by the way. Lobusha says we covered it and I understand. And we don't have time. Baby G is like, yes, Mr. Say, we don't have time. That's very true. All right. Hence, like I said, this is literally a crash course. It's not even like a full lesson. Okay. No, Baby G, don't tell people to go sleep. I mean, it's okay for her to actually share with us whether she's covered it or not, and if she understands or doesn't. I mean, that's important. Okay. So let's not, please, let's not pull out, let's go sleep type deal on other people. Let's not be obnoxious on the comment section, please. We tried covering it back, it's not getting in. Yes, please, I'm writing next week Monday. Please start all over. Okay, guys. Okay, just hang tight with me here. All right, I think I'm gonna do. Allow me to teach you whilst going through examples. I will explain as I do things. All right, just allow me to go through these things as I go through these things with you, then I'll explain. All right, but for now I just wanted to expose you to the form. When I do the actual questions, I will explain, I will unpack, all right, so that you guys get onto the understanding tip. Okay, just allow me though, give me a chance to basically go ahead and do what I've been doing. Okay, so all I did here was to just kind of summarize here on the side that, for instance, we have 4 types of functions. So y is equal to mx plus c refers to our straight line function. Please take note of the standard form of the linear or straight line function. Y is equal to mx plus c. All right. Now this m and this c can be replaced with other letters of the alphabet. What's important is to understand that this m refers to something that we refer to as gradient of the line, okay? The gradient of the line, okay? And then the C has to do with something called the y-intercept, where the function cuts the y-axis, okay? So for now, okay, what about the times 1? Okay, I don't understand, what do you mean by times 1? Or do you mean the exponent 1? Yeah, this exponent here, I just revealed it to show that this variable of x is not raised to the power 2, it's not raised to the power 3. This variable of x is raised to the power 1. That's what I wanted to indicate. Linear has to do with when the x variable has as its highest degree 1. The exponent that is there is 1 for a linear. Linear means exactly that x must be raised to the power 1. Okay? Yeah, so it is just x, and that x is just there. Okay, so I hope you understand that. So y is equal to mx plus c. The person who's asking, when are you going to do this practice for grade 11? Okay, I'll be doing this practice for grade 11 the weekend. But more than that, in my YouTube channel, this lady who's just asked about grade 11, I've been doing grade 11 live lessons on functions. So I've posted all of the sessions that I've done with the grade 11s onto my YouTube channel. So you can hop on there and check them out. I've done straight line, linear function. There's a playlist that I have there for grade. It's called grade 11 functions 2025. And it's the entire playlist for all the linear functions, parabola, hyperbola, and your exponential function. So please go check it out. Okay, the YouTube link for my channel is on the bio. It's in the bio. It's called Maths is a Game. Everything is Maths is a Game, guys. Everything is Maths is a Game. Maths is a Game. Together, capital letters 5 to 7. Just check it out. The link is in the bio. Please, you can check out. I've done this practice. We've answered exam questions for the grade 11s. Like, I've covered the content for the grade 11s when it comes to functions. So those are the people that should be sorted more than any other people when it comes to the functions. That obviously also helps the grade 12s, because grade 11 functions and grade 12 functions, we are pretty much speaking the same language. The basics for functions is in grade 10, and this is basically what I'm trying to do now. Just help the grade 10s be on board with the functions. So let's come back here. So like I was saying, the linear form is always y is equal to mx plus c. This is the general standard form of a linear function. Now someone else might be like, so what if they give me the function like this? Let's say you have y minus 2x is equal to 7. It's your responsibility, guys, to make sure that y is isolated on the left. And then what do you do to the negative 2x? Okay, because you want the function to be in this form, because you can see, guys, that the x has the exponent that you cannot see, that is 1. So this is definitely a linear function, but it's just not in its form. So what we would do, we would take the negative 2x to the other side, and then this presents us with the form of the function that we know, which is the linear form. Okay, so please, guys, it's important that your linear function is in the standard form. So this form is very important. Y is equal to mx plus c. The minute it's in this form, then you can tell me something about the gradient of the function. What is the gradient? The gradient signifies how steep the line is, how steep, all right, the line is. Okay, so that's very important, that when you have the function of the linear form in standard form, then you can tell me, oh, what is the gradient of the function? The gradient of the function is the value of it's the m value, the coefficient of x. So the gradient would be 2, all right? Okay, because this m value tells us about the gradient of the straight line. Okay, so for instance, when a straight line is in this shape, we say this is a positive gradient. If the straight line is in this shape, we call this A. This has a negative gradient. Then if your straight line is horizontal, like this, from left to right, we say that the gradient is equal to 0, right? And then here, if the line is vertical, we say that the gradient is not defined. So here the gradient is positive because this is an increasing straight line, okay? Then here, the gradient is negative because this is a decreasing straight line. Then here, the gradient is equal to 0 because this is a horizontal line. And then here, the gradient, we say that the gradient is not defined, it's undefined for a vertical line, right? So all of these things, they are important things that we need to just note when it comes to our straight line function. So guys, simply put, by doing this, I just wanted to show you that for a linear form, this is the form. Y is equal to mx plus c. Okay, so I hope you understand this part, because that's what I wanted you to understand. Second function is called the exponential function. Now, I'm hoping you guys can observe, if you look at the linear function, which is a straight line, and the exponential function, you see this y? There's a y there as well. Equal. Now, mx, look at the exponential function. ab to the power x. You see this x in the numerator, but it's not an exponent. This x is an exponent. So that means that this here, for an exponential function, our x value can never be like this. Because if it's like this, it's a linear function. But if the x is an exponent, then it means we are dealing with an exponential function. The minute the x is an exponent, we are dealing with an exponential function. And that's very important to note about your exponential function. So it's ab to the power x plus q. That's an exponential function. This is the form of an exponential function. I will explain further, guys, what a and b and q do. For instance, even here, I'll explain further what the c and the m, they basically mean. Let's move on. We then have a parabola or quadratic function. That's the third type of function we have. And the form is y is equal to ax squared plus q. Now, please take note, guys, with the parabola. You see, with the linear function, you remember what I said about the x? The x has an exponent of 1. That's why we say linear. But look here, y is equal to ax squared. You see the difference between the x here for quadratic or parabola? Do you see the x here for the linear and the x here, that is an exponent? Surely you guys can see the difference. Okay, very, very important. You see the difference. So the y is equal to mx plus c for a linear function. That's the linear function. The x value, right, has an exponent of what? Exponential function. The x variable is an exponent. It is not like this and it is not like that. So exponential function, the x variable is an exponent. Yes, you can ask Kalo. You can ask parabola or quadratic function. So the word quadratic has to do with the fact that your x is raised to the power 2. That's what quadratic means. It has to do when your variable in your expression, the variable, the highest exponent that is actually there for the variable x will be to the power 2. So that's what quadratic means. Linear, on the other hand, means your variable x, the highest exponent will be 1. Quadratic means the x variable, the highest exponent will be 2. Right? So parabola and linear are not the same, in that when you look at your x, even though both of your x's are, look at them, they are all in the numerator, but they are exponents. For linear, the exponent is 1. For quadratic or parabola, the exponent is 2. And then for your exponential function, like I said, it's the variable x that is an exponent. It is an exponent for your exponential function. So hopefully now you can distinguish between linear form, exponential function form, parabola or quadratic function form. Okay, and please guys, your parabola is either going to be a huge smiley face, or you're going to be down in the dumps, sad like nobody's business. Happy face or sad face. And I will explain later why sad, when is it sad, when is it sad, when is it happy. You know, this is like a smile face. If you think about it, look at this, like these, smile, and then sad. Like some of you are sad because you are writing on Friday. Okay, so ax squared plus 2, this is the form for your quadratic function. Okay, this is your quadratic function form. Y is equal to ax squared plus q. Okay, very, very important. Then I want to go and address our last type of function, which is called the hyperbola. The hyperbola function. So the hyperbola function has this form: y is equal to a over x plus q. A over x plus q. Right? And then, very importantly, hyperbola can either exist like this in the first and the third quadrant, or the hyperbola can exist like this in the second and fourth quadrant. Right? And obviously that depends on certain aspects where the function is concerned. So what I wanted to do, guys, just in summary here, is I wanted to expose you all to the form of each function. Linear, mx plus, well, mx plus c. Some people use ax plus q. Maybe for some people it's like they don't see it when it's mx plus c, they see it when it's ax plus q. Okay, you can see that the a and the q, guys, I mean, doesn't really matter. Okay, doesn't really matter. But what's important here is that ax plus q, the x variable, is in the numerator with an exponent of 1. That's how we know it's linear. This is going to be a straight line function. All right. Okay. Then exponential function, ab to the power x plus q. As I said, here the exponent, the variable x, is in the exponent. Yes, they can, Lerato. They can, definitely. Then for this one, parabola, y is equal to ax squared. Remember, I said quadratic means the x variable, which is in the numerator as well, has an exponent of 2. So that's why it's different from linear, because it has an exponent of 2. Okay? Plus q. All right. Then the hyperbola function, guys. Y is equal to a over x plus q. Okay? For grade 10. Lulama, this is grade 10. Y is equal to a over x plus q. So you can see with the hyperbola, the function has a variable of x in the denominator. In the denominator. I hope you understand. So the x variable is in the denominator for your hyperbola function. Okay? Okay. Now all of these very, very important. These different types of functions. Okay. Now let me do a quick overview then with you guys, because it seems like an overview is important here. Otherwise, I'm gonna lose most of you. All right. So summarized overview. Y is equal to ax plus q. Which one did we say this one was, guys? You tell me. Linear, exponential, quadratic, or hyperbola? Linear, quadratic, exponential, hyperbola. Let me check. Let's test that first. Because if you can't identify this, guys, the form, hey, matata kifela. All right. Okay, I see in the comment section everybody saying linear, 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 linear. Very good. So this is a linear function. Very, very good. All right. And our justification is the variable of x is in the numerator. And maybe some of you are like, but why is this guy insisting that it's in the numerator, this x? Remember that a over x, you know, if we were to reveal what's in the denominator, we can write ax over 1. Are you with me? So that's why I'm insisting that this x is in the numerator. Okay, and that's why it's important to note this, because this is a linear function. Linear function, ax plus q. Now let's talk a little bit now about the a value. All right, the a value, guys, as I explained to you, stands for gradient. Okay, this is the gradient of the function. A stands for gradient. Okay, a stands for gradient. Okay, that's what it is. Now, yes, baby G, remember I said a and q. I mean, y is equal to mx plus c, same thing, right? Remember, the m and the c are just letters that you can choose any other letters. We could choose p and n, l and p, c and d. All right, what's important here is to just understand that it's a letter, any letter, and then the x follows that, plus or minus any other letter. All right, so what's important here is that these letters, okay, we just need to understand what they mean. So whether it's m or a that we are talking about is not of importance here. Remember that your m and your m or your a stands for gradient. Now, your gradient value can either be a positive value. In other words, it can be a value that's greater than 0. What you will notice is that when you sketch your function, your straight line function will be an increasing one like this, right? Whenever a, which is the gradient, or m is greater than 0. In other words, it's positive. Then what you're going to have is you're going to have an increasing function. Yes. Looking at the function, you must be able to identify the graph. Yes, very important. Okay, so when your a or your m is positive, you have an increasing function. When your m or a is negative or less than 0, then you are going to have a decreasing function. Okay, this is grade 10, guys, introduction. Okay, if your m is less than 0 or your a is less than 0, you're going to have a decreasing function. This will be your shape. Okay, yeah, so that's why we say the a or the m actually exposes us to the shape of the function. All right, okay, so if m is greater than 0 in this form, then we know it's an increasing function. If m is less than 0 for this linear function form, then this will be the decreasing function. If m is equal to 0, guys, then we know that your function is a horizontal line. Okay, gradient is 0, you have a horizontal line. Okay, and then lastly, there are situations where m is not defined. Okay, m is not defined. When the gradient, guys, is not defined, then you are going to find that the straight line is a vertical line, and it will usually be given by, it will not be y is equal to something, it will be x is equal to some constant value. Okay, so it becomes a bit unique when your gradient is undefined. In actual fact, whenever you see a vertical straight line, that vertical straight line has the equation x is equal to. It is unlike your form where your function is y is equal to something. Your vertical straight line will be x is equal to some constant value. All right, and that's very important to note. Your horizontal line, on the other hand, will be y is equal to some constant value as well. Okay. All right, guys, I'm going to push this live as far as I can. I'll probably end even at 12, most likely, because I'm trying to really establish for the grade 10s to, like, tonight, like, what these functions are about, at least so that they have a semblance of what these functions are about. So now you see this a value plays, or this m value plays an important role in the shape of the function. It is basically the gradient of the function, first and foremost. And whether, if the gradient is positive, you have an increasing straight line. Because as your x value will increase, your y value will also increase. All right. When it's less than 0, the gradient, then it will be a decreasing function. Okay. This is your shape that you can expect. When m is equal to 0, it will be a horizontal line. Okay. And then if it's a vertical line, guys, we know that the gradient is not defined. Hence, even the equation is a bit or slightly different in that it will be x is equal to some constant value. All right. Right. So that's very important to note. That is like the foundation of a straight line function. We need to understand the effect of the gradient. Then there's this value of q here. Okay. This value of q. This q value will tell us something that we basically refer to as our y-intercept. Okay, that's for a straight line. What is y-intercept? Where the function cuts the y-axis. Where the function cuts the y-axis. Okay? Where the function cuts the y-axis. Okay, I'll show you guys. Yeah, I'll show you an example just now. Okay, I'm getting there. Okay, I'm gonna show you an example for each one just now. Okay, I'm gonna show you just now. Just hang on. Okay, so this is for a straight line function, because remember, guys, we are dealing with a straight line function here. So if we're dealing with a straight line function, okay, then like I said, if the gradient is positive, we are having an increasing function. And for a straight line, all right, as long as the gradient is positive, we know that the function will be increasing everywhere. Okay, it will be increasing everywhere. For a straight line function, if the gradient is less than 0, then the function will be decreasing everywhere. Okay. As long as the function in and of itself is actually unrestricted and there are no restrictions at all. From left to right, the function is available. Then if the gradient is equal to 0, this function is neither increasing or decreasing, rather it is a function that is basically going to be constant. And then here, if the gradient is undefined, then it is vertical. Okay. Yeah. So we are still dealing here with the straight line function, not with the parabola yet. Okay. So I will talk about parabola as soon as I get there. Then, like I said, the q value, guys, the value of q, this q value, what does it speak to? It speaks to what we refer to as the y-intercept. What is the y-intercept? It's where the function cuts the y-axis on the Cartesian plane. Okay. Now, what is a Cartesian plane, guys? A Cartesian plane is simply a system of y and x-axis. So our Cartesian plane will have a y-axis and the x-axis. And what you'll see there is you'll see a number line. Okay? You will see a number line represented on your y and your x-axis. Okay, so on your x-axis you'll see values. There you'll have the origin, which is 0, and then here you'll have numbers, right? Okay, negative numbers on this side, negative numbers underneath here for our y value, and positive numbers here for our y values. So here you have positive x values, here this side you have negative x values. Okay, then here we have positive y values, whereas here below this line, the x-axis, we have negative y values. Okay, so that's very important. Okay, very, very important. So if, let's say, I was to populate, okay, let's just, okay, then this is basically what one would be able, okay, to see. Okay, you would see a number line. So there's a horizontal number line, which is your x-axis, and then you have a vertical number line, which is your y-axis. Very, very important. So we have all of these, and this is what we call the Cartesian plane. Okay, very important, the Cartesian plane. All right, so guys, explore with you a little bit. Let's say we were given to sketch the function y is equal to x plus 1. Okay, yes, baby G, I see your hand there. What is the issue? Let's say you were given the function y is equal to x plus 1, and they said to us, sketch the function y is equal to x plus 1. Okay, remember, they could use the alternate notation and say f of x is equal to x plus 1. Remember, guys, that at the end of the day, okay, y is equal to x plus 1 opposed to f of x equal to x plus 1. Remember, what did we say? F of x stands for y. All right, so y and f of x are the same thing. Okay, yeah, x is negative on the left. Okay, x is negative on the left, y is negative down. Okay, so x is negative on the left, y is negative down, y is positive on the top, x is positive on the right. Okay, very important on your Cartesian plane, because if your orientation of your Cartesian plane is wrong, then it means when you sketch, you are going to be sketching completely wrong. So it's very important to understand that your Cartesian plane needs to have negative values on the left of x, and these are negative y values down here. At the top we have positive y values, and then on the right here we have positive x values. Okay, that's very important. Yes, baby G, it is. Okay, so y is equal to x plus 1. Let's say we were asked to sketch this. Now, already in grade 9, you guys were taught a method that we refer to as the dual intercept method. Okay, the dual intercept method. Okay, dual means two, intercept method is just the way in which we find the x-intercept. Okay, which means we let y is equal to 0. Remember, by x-intercept we mean where the function cuts the x-axis. Okay, that's the x-intercept, where the function cuts the x-axis. Yeah, you will continue to be lost, Mosi. You guys are having a fun time in the comment section, so you'll definitely be lost, because I think some of you are focusing so much more on the back and forth interaction in the comment section, and then what's happening is that I'm saying things here, you guys are enjoying comment section stuff, and then you are losing your concentration there. Okay, So be very careful, be very mindful. It's the same sort of like mindset that learners tend to have in the classroom. Some of you are missing out on so many things that are being taught in the class because you spend most of your time wanting to have chit-chat moments with your mates. And when you do, what happens is you get sidetracked completely. You don't understand a thing of what's happening on the board. The teacher will teach and teach and teach and teach and finish 30 minutes or 40 minutes of good, important time where you could have gained a lot is time wasted. And then you move on to the next topic and you are like, I don't even know what happened in the previous section that we are doing. And that's where I think a lot of the downfall comes with a lot of you when it comes to your maths. So, and I know this because I deal with it constantly in the classroom. And I've had to really try and get my learners to understand why it's so important for them to be focused on subject matter when I'm dealing with it. You see, so it's very important. I'm not saying you can't comment, but you need to comment within what we are doing so that it stays within the context of what we are commenting. I think some of the comment sections, they get sidetracked and there's other discussions you have, so the focus is there. I'm saying things here, you miss that out, and then it's like you come back and you're like, sir, can you repeat that thing again? And yeah, that's where it goes wrong for you as an individual. All right, so yeah, let's try and just be on this, né? Please. So y is equal to x plus 1, like I said, y is equal to x plus 1. We can write this as f of x as well is equal to x plus 1. Because remember I said y and f of x are the same thing. Okay, y and f of x are the same thing. So like I said, guys, what you can do is you can use what we call the dual intercept method to sketch the function. So by dual means two. Intercepts, there are two intercepts that we talk about on our Cartesian plane. We usually speak of the x-intercept. Now, if you're talking about x-intercept, you are talking about on your x-axis. What do we know about our x-axis? We know that on the x-axis, y is equal to 0. Everywhere on this x-axis, guys, the value of y is 0. Here, 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 the value of y is 0. Everywhere on this line, the value of y is 0. So we can then say, to find our x-intercept, let y be equal to 0. So we go to our function, we write it down. And remember, if you are saying let y be equal to 0, it means in the place of y, you are going to substitute what? 0. Then what are you going to do after substituting 0? You are going to solve for the variable that is there. So meaning we are going to solve for x. So when we solve for x, surely by now we know, we take the 1, we transpose it, we get -1. So x has been isolated, all right? So x is equal to what? Therefore, we can say x is equal to -1. Make sense? So that means if we were to write our coordinates, coordinates, all right, what is that? Your x and your y value that you got. Remember, you substituted an x value, you substituted a y value of 0. And then after substituting a y value of 0, you got an x value that is -1. All right. So our coordinates for the x-intercept are -1 and 0. That's how we read this. We read it as -1. The semicolon means and, -1 and 0. And we put brackets around the -1 and the 0 to indicate that these are our coordinates for the x-intercept. Okay, so guys, remember, whenever we want to find the coordinates of the x-intercept, we let what? We let y be equal to who? 0. We substitute in the place of 0 in the function. Remember, y is 0, so we substitute in the place of y 0. There it is equal to x plus 1. There it is. Then we solve for the unknown, which is x, which means we take the 1 over. It becomes what? 0 minus 1, which is -1. So x is equal to -1. Okay, so since we let y be equal to 0, remember, who is 0? It is y. Okay, what did we get when we substituted y that is 0? We got x that is -1. Here it is. Okay, then number 2, because remember, dual means 2. So this was the first intercept. Now we go to the second intercept, which is called the y-intercept. What is the y-intercept? It is where the function cuts the y-axis. So on the y-axis, what do we know? We know that everywhere on the y-axis, the value of x is equal to what? Everywhere on the y-axis, the value of x is equal to what? Thank you, Tori. So it is 0. Thank you so much. So on the y-axis, for the y-intercept, we let x be equal to 0, guys. Okay, then we go to our function again. We rewrite it. And then in the place of x, what do we substitute? 0. Y is equal to 0 plus 1. Then I'm sure you can see, guys, what the value of y is. Y is equal to 1. Okay, so our coordinates now for the what? For the y-intercept, what are they equal to? They are equal to, remember, x was what? It was 0. What about y? Y is 1. So our coordinates for the y-intercept are 0 and 1. Okay, I hope we are together. We are flowing together very nicely. Now we are ready to sketch our function. Where? On the Cartesian plane. We are ready to what? To sketch what? Our function. Where? On the Cartesian plane. Why? Because we have the what? We have the x-intercept. All right? And we have the y-intercept. The coordinates, in actual fact, of the x-intercept and the y-intercept. So let's go to the Cartesian plane and locate these points. Okay, this point, which is the x-intercept, -1 and 0. Where is -1 and 0? Where is x -1? Let's go there. Where is x -1 on the Cartesian plane? There it is. X is -1. Sorry, here. X is -1 here. Okay, Tori, so there will be no turning point. Remember, this is the sketch of a straight line. Y is equal to x plus 1. Remember, there is no x squared. This is x plus 1. Okay, hopefully we are together, Taurus. Okay, because you are saying, show me the turning point afterwards. How can there be a turning point when we are drawing a straight line function? Right? We have established that this is a straight line. So let's be very careful. Okay, that's why at the beginning I first went through these so that we can understand. Straight line function, y is equal to mx plus c. This is the form for a straight line or linear function. Exponential function, y is equal to ab to the power x plus 2. X is an exponent. That's why we see it's an exponential function. Parabola, or your quadratic function, y is equal to ax squared plus 2. That's where we have turning points. Okay. Then lastly, hyperbola, y is equal to a over x plus 2. The variable x is in the denominator, so that's why we know. So I know from the get-go, from this sort of question that I have here, I've been given f of x is equal to x plus 1 or y is equal to x plus 1. This is a linear function. It's a straight line. So when I sketch it, I know that I'm going to be sketching something I already know in my head. Okay. Yeah, it's in the form. Very important, the form. That's why I started off by explaining to you what is the form. Okay. As always, we have baby G there in the comment section. Yes, very true. we have a positive gradient, Tori. So you are seeing it, my Lita, you are seeing it. Y is equal to x plus 1. The coefficient of x is positive 1. So the gradient of the function is positive. You've got it. You've got it. Tori, so you are touring, my Lita. You are touring. I see you are touring there in the comment section. Touring as well with the answers. Okay, so the coordinates, sorry, let's go back to the coordinates. I wanted to locate -1 and 0, where my x value is -1 and where my y value is 0. Where is my x -1? X is -1 here. You see, this is the x-axis, and my x is -1 exactly there. Where simultaneously is y equal to 0? We'll remember, guys, that y is equal to 0 is everywhere on the x-axis. Y is 0 everywhere on the x-axis. So therefore, it means this point here is my -1 and 0, where x is -1 and where simultaneously my y value is 0. We are here. We are visiting here. Yeah. -1 decided to take 0 on a date. The question is, where are they meeting for the date? -1 is here at home, all right? 0 is along this line everywhere. Y, that is 0, is along everywhere on this line. So where are we meeting? We are meeting at -1's home for our date. I think it will be a family date with the family and everyone there. So -1 and 0 is here. That is the point -1 and 0. Let's go and locate the other point, 0 and -1, where x is 0 and y is +1. Let's first start here. Where is y equal to +1? Let's go. On the y-axis, where is y? That is 1. That is here. That's where y is equal to 1. Here. But where is x equal to 0 at the same time? X is equal to 0 is everywhere on this line. But since the date is between 1 for y and 0 for x, that means where they are meeting exactly there, at 1's place. Family date, all right? So those are your 2 points that you have. And when you connect those points, guys, what do you see? What do you see? A straight line. What form of the straight line are you observing as you have sketched it? This y is equal to y is equal to x plus 1. Okay. Do you remember, guys, the gradient of the function for y is equal to x? What was the coefficient of x here? The coefficient of x. Okay. The coefficient of x was what? Well, what's the value of the coefficient that you don't see here for x? Okay, yes, it's positive. Yes, Sansa, it's 1. And remember, what did I say about when a gradient is greater than 0? I said you are going to expect an increasing function. What do you observe here? Isn't this an increasing function? Guys, it's not by mistake. It's not by mistake. It's an increasing function because our gradient to begin with was positive. The form of the function, okay? Yes, Reborn, it's increasing from left to right. It's increasing from left to right. Okay? Yeah. So as x increases for this function, y also increases. You see? So that there is how we sketch a straight line function. Very straightforward, ne? Very straightforward. Wasn't it straightforward, guys, to sketch that straight line function? Okay? So please, guys, the dual intercept method is there, okay, for you to sketch a function whenever that particular function. It's the dual intercept method is there for you to sketch the function whenever you have an actual value for q. Okay. Okay, Miss Kumar is suggesting there in the comment section that we write the domain and the range. Before I even talk about that domain and the range, the question is, do we know what domain is and do we know what range is from my learners? Or do we need to explain what domain and range is first? Or are we speaking about something new? Baby G is like, no. Sanetemba is like, yeah, we know. We know. So Not really, Rere says Rere means not really. TK says no, explain domain. Not that guy. Kek says please explain. All right. So let's look at this word domain. Okay. So the word domain is left to right. All right. I love this. Okay. And maybe if you are saying is left to right, maybe you need to ask yourself, from left to right, what do you see? You know, from left to right, you see the values of x from left to right, from left to right. So I love the fact that someone has said in the comment section, from left to right. That's what they are thinking about when they think about domain, from left to right. So the domain, we say, is the possible x values. Okay, you see I'm using x, the possible x values where the function or graph, where the function exists or is possible. And we look at it from left to right, because x is observed from left to right. I love the from left to right. It is the possible x values where the function itself, the function that you have sketched, you see the straight line here, where the function exists, or where that function is actually possible from left. When you look at the function from left to right, where is it possible? So when we look at this function, we're looking at it from left to right, and we're asking ourselves, is there a place where this function is not possible, or where the function does not exist? Now, from left to right, will you ever have a situation where the function will not exist? Now, guys, please take note of something here. You see this arrow here? This arrow is an indication that from the left, this function, hey, is forever existing. It's like got an endless existence, this thing here. This arrow indicates, we are not stopped. We have not stopped here. We would go on forever and ever. Look, go. Where are we going? Hey, where are we going? Where are we going? Hey, we are going though. You know, from the left. Now to the right, look at the arrow at the end here. It indicates that this function to the right, hey, it's going. Where is it going? Where is it going? All right. Is it ending anywhere? Is there an end in sight on the right? Is there an end in sight on the left? That's the question. Okay. And in between, do we see the function's existence? Okay. So I love what Torres was saying in the comment section. It exists, the function exists everywhere from left to right. So then if the function, okay, is existing everywhere, we you know, you're like, is there a place where I will not touch the function if I'm moving from left to right? Given that this arrow, like I said, is going on forever now, is there ever going to be a place where when I move this pen, where the function is not going, where the pen is not going to be touching the function from left to right? You know, so that means the function will be existing everywhere, because there's no place where the function does not exist. So guys, I ask you this, that whenever you think of domain, you are always asking, from left to right, from this side to that, as I move from left to right, is the function going to have a place where it's not going to exist? Or is it existing everywhere? That is the question, from left to right. So I love what people have said in the comment section. The function will always be touching, meaning the function will be existing everywhere. So for this straight line, the one that we have there, we can either say x is an element of real numbers. In other words, the function exists for every real value you can imagine. Remember, real numbers include rational and irrational numbers. That's all the numbers in the number line. Hence, in the number line, okay, that includes all the numbers, even the ones that are in between. Okay, you know, so it's very important. So x is an element of real numbers. Yeah. We even 0, where x is 0, the function exists. Remember, when x is 0, y is 1. Okay, so the function is existing even there. So there's no restrictions, there's no limits. X is an element of real numbers. Okay, it exists even where x is 0. You see, Moss, it exists because y is 1 where x is 0. So the function exists. So we can say x is an element of R, or we can say x is an element. Some people like this one. You know, that 8 that has slept, decided to fall on the ground, negative infinity, you know, to positive infinity. You can say x is an element, open brackets. You use open brackets from negative infinity to what? To positive infinity. So that is domain, guys. Domain, we are always looking from left to right. Okay. Infinity is just a mathematical concept that means numbers go on forever and ever on the right, numbers go on forever and ever on the left. There's no end to number in the negative direction, no end in the positive direction, no end in sight. Okay, forever and ever. Okay, I'm guessing the only infinity love that will ever exist is in the functions that basically forever and ever. When I will say I will love you forever and ever, and then tomorrow you've changed your tone. Okay, range. Okay, yeah, let's look at range. What is range? Range is the possible, now instead of x values, now we are talking about y values, where the function exists or is possible. From where? From bottom to top. Yeah, from bottom, from the bottom. Started from the bottom, now we here, you know. Started from the bottom, now we here. Started from the bottom, now we here, you know. Yeah, started from the bottom, now we here. One day you guys will say, I started from grade 10, now I'm here. When you'll be in grade 12 by that time, you'll be like, I started from grade 10, now I'm here. Started from the bottom, now we're here. Don't forget, range is the possible y values where the function exists from the bottom to the top. Bottom to the top. Why bottom? Because remember, at the bottom of the Cartesian plane, your y values, those are your most negative values. Then you go up to the top, that's your most positive. You see, from the bottom to the top, from the bottom to the top. Does that make sense? So for this straight line, the question is, this function, remember you said the arrow, I said this arrow goes down, goes on forever and ever and ever and ever and ever and ever. Not only to the left, but to the bottom. But to the bottom. Then here, not only, you know, to the right, but to the top, to the top, to the top. Is there top of top tops? Or do we just top all the way? So this function from the bottom, is there a place where this function is not gonna exist from the bottom to the top? There's nowhere, guys. Everywhere this function exists from the bottom to the top, because it's an infinite, non-restricted function. From the bottom to the top, the function will be existing everywhere. Does it make sense, guys? Okay, does that make sense? From the bottom to the top, the function exists. Hey bana, the function exists from the bottom to the top, because this will continue, you see. So then what are we gonna say is the range? Okay, what are we gonna say is the range, guys? Okay, I'm happy it makes sense. What are we gonna say is the range then? If from the bottom to the top, the function exists everywhere. I'm hoping you guys know what we're gonna say. Gladwin, you make me glad. Yo, Gladwin, you make me glad. Y is an element of R. Very good. Y is an element of R. Or if we don't want to say y is, remember Landi, when this time around we are not talking about x values, we are talking about y values. Make sense? Because for range, it's not x, it's y. Remember, if we are saying started from the bottom, remember, from bottom to the top, we are talking about y. Do you see, Landi? We're talking about y. Okay? On the y, you see, the y-axis, bottom to the top. So we say y values, not x. So it's y, all right? That's why we say y is an element of R. No problem, Nandi. Okay, y is an element of R, meaning y is an element of all real numbers. Or if you don't want to write it that way, you could say y is an element of negative infinity to positive infinity. And that's a beautiful range to be written for your straight line function. Okay. Any debuts or any questions? It's very important, this range and domain stuff. All right. And thank you to the miss that actually indicated in the comment section. You might as well write the domain and the range whilst you're at it. Okay. Thank you. Lerato is saying no what? Okay. All right. So once again, I first explained what domain is. And we said domain is the possible x values. Okay. Domain is the possible x values where the function exists. All right. From where? From left to right. Because if we are talking about x values, we are talking from left to right. So on the Cartesian plane, from left to right, these are what? X values. You can see negative x values, positive x values, positive. From left to right. So where is the function existing? And we can see, we said that the function from left to right, because the arrow there indicates, hey, it's going on. Arrow there indicates go. So to the right, it goes on. To the left, it goes on forever. So from the left to the right, the function exists everywhere. Right? So what we can see, we just need to ask, where does the function for x from left to right exist? So we can say it exists everywhere. So everywhere means x is an element of real numbers. Okay? Or we can say x is an element, negative infinity, open brackets, to positive infinity, open brackets. This is interval notation. So that's why the semicolon doesn't mean and, it means to. Negative infinity to positive infinity, open brackets. Okay, so thank you to those there in the comment section. yeah Okay, then if the line Galoko has no arrow, if the line now it all depends, right? Sometimes they give you a restriction to the domain. Okay, now typically for most functions, when they sketch them, you know, your functions typically should have the arrows. Okay, so for instance, look at this. I'm just looking at your past papers here, right? Past paper functions. When they've sketched your functions, you can see, look at this, you see? This is an exponential function, and then this here is a hyperbola function, and then the same system of axes. You can see, guys, that the sketch here is beautifully sketched. Look at this one. See the straight line? Okay, key arrows, all right? We've been given the equation h of x is equal to negative 6x plus 20. Now look at the function h of x. This h of x, if you look at the straight line, it has the h there to signify that it is h of x. All right, h of x is equal to negative 6x plus 20. What is the gradient here in this function? Let me see if you guys know. What's the gradient of the function, the straight line? Tell me. From the form that you see, what's the gradient? Okay, Lerato says negative 6. Gradient is negative story, so not that guy. Akenene, Pabalo. Okay, seems like we are all on the roll. Cutie pie, Orabile, Ori. Right? And what are you expecting since the gradient is negative? Do you remember what I said about the shape of the function? When the gradient is less than 0, you can expect a function that is decreasing. Now guys, look at your function here. Do you see? Look at your function. They sketched it for you. It's decreasing. You see? Guys. Sir needs fiber. You guys are hilarious. It's good now. It has negative gradient. Gladwin is very funny. You are a funny guy. You're a funny man. You're a funny guy, Gladwin. Gladwin is like saying this network is decreasing. It has negative gradient. But I must commend you for actually using a situation, you know. Yeah. Well, okay. So hopefully we all understand. You see, gradient positive, right? You can see it graphically. Gradient negative, it should be able to also display graphically. I was wanting to speak about this. Q speaks about the y-intercept, okay, for your straight line function. That's where the function cuts the y-axis on the Cartesian plane. So hopefully we all are good on the money with that, where that is concerned. I just wanted to speak on that, okay. Then, guys, I'm going to turn our attention away from a straight line for a little minute and just turn my attention to something else now, just quickly. Your parabola. Remember, I'm just trying to get you guys in because I can see some of you are warm, but some of you are cold. So I'm just trying to get us a little bit warm. Okay, so y is equal to ax squared plus 2. What form of the function is this one? Let's see in the comment section if people know. What form of the function is this one? Parabola, straight parabola, or quadratic, exponential, linear, hyperbola? Which one? Okay. Oh, look at these people interplaying with the words. Some are saying parabola, some are saying quadratic. Okay, so guys, all in all, that's a parabola function. Very quickly about this one. This one is very straightforward. If a is greater than 0, now anything that's greater than 0, guys, we know it is something that is positive. Yeah? And if we are positive, it means for the parabola, we smile, guys. Smile. And then you know how AMA 2K do the things today. They like sticking out their tongues. I don't know for what. But AMA 2K, they just do the things. This brand of young people, this generation of kids, right? Yeah. So when we are positive, guys, we do all sorts of things. We smile, we have a good time, everything is pashashi, you know, so it's like that. So this is the shape that you expect or anticipate whenever your A value is positive. You expect a concave. We say formally this is concave up. All right, concave up. We say it's concave up. But when I will say smiley face, I mean, just so that you can remember that when you are positive and you are happy, positive means you are happy, you are in a good mood, you smile, you know, from ear to ear, you do that. All right, hope that makes sense. Then, what about when a, the coefficient of x squared, is negative? What do you do when you are negative, guys, and the vibe is not so great? You are not vibing with anyone, you know? Then what happens? Hey, you are sad, Baba, you are sad. Look at that. You want to cry even. Tears come down your cheek. You have so much on your mind. You want to cry. Boo-hoo-hoo, you cry. So that's concave down. Mathematically speaking, they say it's concave down. Sad face is sad day, you know? Yeah. That day when you finally leave your parents who you think are such an irritating, you know, bunch of people and they are boring and backward. That day when you leave and you have to go to varsity and you want to cry, boo-hoo, and you are there that side and life is getting tough there in varsity and you cry, boo-hoo, you miss them. That's the when A is less than 0, negative, concave down. So hopefully that makes sense, guys. That's the A value. Now, please, guys, this A is not gradient. This is not gradient, guys. It's not gradient, please, right? So in our minds, we must distinguish between when it's a straight line function or a linear function or linear form, that M stands for gradient, Okay, but here this a is not gradient. This is simply what? It's simply the coefficient of x squared that will tell us about the shape of the function. When a is positive, we are happy. When a is negative, we are very sad. Concave down, concave up. All right, yeah, so hopefully we understand that one. Q for the parabola function, this here is also the y-intercept, but in grade 10 it's also something else, and it exposes us to something that we call the TP. What is the TP? The turning point. Someone in the comment section was so eager to actually get exposed to this. So this is the function that has a turning point. All right, because you can see there that as we are smiling from ear to ear, there's a point where we turn. Okay, that lowest point, we call this the lowest or the minimum point for our parabola function. This one we call the what? The highest, or the, I'm looking for that other word that people want to use here. The highest or the, here I said the lowest or the minimum. Here I say the highest or the, look at this guy. Is the one that basically commented the word I wanted, maximum point. Okay, then someone in the comment section was very quick to tell us that when it comes to movement of the function, movement, our function can move up or down. So when our q value is greater than 0, it implies that the function had shifted up. But when our q is less than 0, it implies movement down. Make sense? Q greater than 0, positive, upward movement. Q less than 0, negative, downward movement. Okay, here we go down, here we go up. So Q has this role of actually moving our function up and down. Okay, so if we are to say add more to Q, it means we are moving the function up. If we subtract something from Q, it means we are moving the function down. All right, it implies that. So very important that more than just the Q value telling us about the y-intercept and the turning point, we can obviously get the coordinates of the y-intercept and the turning point, because our Q value can help us with that. But also more importantly, the movement of the function up and down is dependent on what we do to our Q value. Okay, we add things to our Q value, it goes up. We subtract things from the Q value, it goes down. Okay, yeah, Toriso is saying some important stuff in the comment section. Hopefully you are taking note. Toriso did indicate that he was someone that did grade 10. Now he's here giving some wise words of wisdom there and guidance as needed. Yeah, thank you. You're very kind, Toriso. And for someone to actually be in this live session and to be contributing as positively as you are doing, it's a very needed and a very positive thing. So thank you so much. You are a star, my leader. You are a star in the truest sense. So very important that. Okay, so hopefully we understand now. Okay, so let's just for a moment there. Glad we try and take one thing at a time. All right, of course for grade 10s, that language is something that we reserve for until grade 12. When we are in grade 12, we speak about it when we are referring to the other type, that function that we learned there. But for now, we're just sticking to turning point, and turning point suffices within the grade 10 context. So, but I appreciate what you are saying. I appreciate what you are saying, and I understand. So movement up, down, please guys, very, very key for our function. So I'm just gonna quickly see how we can use then this knowledge and information to sketch a function. All right, let's say we had the function y is equal to x squared minus 4. Very quickly, so let's see first and foremost, is the function in the form that we know? Yes, it is, guys. Y is equal to x squared minus 4. It is in the parabola quadratic form, the standard form, where our a value is 1, so it's positive. So what are we expecting? Even as we plan to sketch we know that because a is greater than 0, a is equal to 1, we are expecting Mr. Happy Face to be joining our Cartesian plane moment of play. And then 2, we can find the x-intercept and the y-intercept. So even here, we can use the dual intercept method, especially when our function is 1, whereby we can see that factorization is possible. If factorization is not possible, guys, please take note that we can always use our calculator to be able to sketch our function, because we'll find that in the situation where we cannot factorize, the only feasible way to be able to sketch our function is to be able to use our calculator. So we do point by point, and the utilization of the calculator is very, very nice and straightforward. But please, we do it only when it is not feasible for us to actually factorize the expression that we have for our function. Okay. So here we can factorize. So we are going to find the x-intercept first and foremost by letting y be equal to 0. All right. So x-intercept, if we let y is equal to 0, what do we have? 0 is equal to x squared minus 4. What is this, guys? Must be familiar, this thing. I'm sure as you are practicing your expressions, your equations, solving for x and so forth, you can see most this thing, x squared minus 4. So how do I factorize it, guys? What type of factorization does this require of us? Difference of 2 squares. How beautiful. Who is this amazing lady there that's commenting? Are you commenting? Are you a grade 10 learner, or are you advanced? And you are just, look at that, sticking out of tongue. You see, look at this. You see, this is what I was saying about my 2K. Look, you see, I spoke earlier on about concave up, smiley face. You can see someone is smiling there in the comment section saying difference of 2 squares. And look, what is she sticking out there in that comment section? Look at this, look at this, look at this. What is this? Look at this. You see? Yeah, so I'm not talking about things I'm not exposed to. Look at this. What is that? I've pinned it there. What's that? My 2K. My tongues. Huh? Hey, you guys, you'll get in trouble with those tongues of yours. I'm just saying. Yes, it's the dual dondoni, my little. X-intercept. There we have it. X-intercept. Let y is equal to 0. There it is. There it is. There it is. You see? Okay, then y-intercept, we let x be equal to 0. There it is. In the place of x squared, we substitute what? Substitute 0 in the place of x. Let y be equal to 0. We have y-intercept now. There we let what? We let x be equal to 0. 0 squared minus 4, that's negative 4. So our coordinates there, what do you have there? Okay. When x is 0, y is negative 4. Guys, I hope you see there. Okay. So those were my x-intercepts. I got 2, x is equal to 2 or x is equal to negative 2. Remember, I initially let y be equal to 0. So it's 2 and 0, negative 2 and 0. Then for the y-intercept, I let x be equal to 0. I go back to the function. I let what? X be equal to 0. That means my y value will be equal to 0 squared minus 4. And that is negative 4. So then those are my points. 0 and negative 4. Okay. Okay. Then in conclusion, I can go and sketch my function. Where? On the Cartesian plane. So let's do it. Let's do it. Let's do it. Negative 2 and 0. Okay. Negative 2, 2. So let's just say 2, negative 2. Okay. Then 0 and negative 4. Negative 4 for who? For y. Negative 4 for y. Negative 4 for y and 0 there. I grab my pencil, I pencilated it, there I turn. Alright, and maybe you're going to ask, Haibo, why did this guy turn there? Why did he turn there? Remember, what is this? My y-intercept. What did I say it also is at the same time? my y-intercept. I also said it's my turning point. So my y-intercept is also my what? My turning point. So therefore, there at the y-intercept, for a quadratic function, I am going to turn where? At the y-intercept. Okay? Because this is also my TP. Just as much as it is my place where the graph cuts the y-axis. Okay? And there it is, guys. Isn't this a smiley face? Smiley, 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 smiley. Y is equal to x squared minus 4. It's smiling, smiling all the way to the bank, getting all the marks, and not having any mercy. No mercy at all. Getting all the marks. Thank you very much. No questions. Okay. Look at these people. Look at that. Petria fela say. Oh, my soul. Monas Bahle. Monas Bahle is like, where is the zero value? Which zero value are speaking about? Monas Bahle. Okay, so I repeat, guys. Remember at my planning, I said a is greater than 0. Why? Because remember, the coefficient of x squared is 1. A is equal to 1. That a is a value greater than 0. So what am I expecting from the shape? Happy face, happy face, happy face, happy face, happy face, happy face, right? Remember, a is greater than 0, so it's positive. It's a happy face, it's a happy face, because a is greater than 0 and positive. Happy face, sticking out tongue. So then a is greater than 0, a is equal to 1, happy face. Then after establishing that okay, a is equal to 1, I know what I'm expecting. I'm expecting a happy face sketch. That's what I plan on having. Then 2, you get your x-intercept. What do we mean by x-intercept? We let y be equal to 0. Okay, so we go there to the function, we substitute in the place of who? Y, we substitute what? 0. Okay, 0 is equal to x squared minus 4. 0 is equal to x minus 2. I factorize the x squared minus 4. I get x minus 2 into x plus 2. So x is equal to 2, or x is equal to negative 2. Okay. Then these are my coordinates. Remember, when x is equal to 2, when y was equal to 0, I got to x is equal to 2. At the same time, when y is equal to 0, I get x is negative 2. So those are my coordinates and points. I have 2 x-intercepts for a what? For a parabola. Expected, because remember, x squared would imply that I'm going to get 2 solutions for x. All right? Because this was able to be factorized, I was able to actually locate those x-intercepts. Remember, at the end of the day, this function is a function that has x-intercepts. Now, that doesn't mean all your parabolas have x-intercepts. Because remember, guys, that for your parabola, some of them, they are actually parabolas that are like this. Okay, so if you have a parabola like this, for instance, if you had a function y is equal to x squared plus 2, the minute you let y be equal to 0 here, you're not going to be able to get x-intercepts, because this function, okay, it's a happy face, but its y-intercept is actually above the x-axis. All right, because the y-intercept, when you let when you let x be equal to 0, you get y is equal to 2. All right, so that would then suggest that, okay, here I'm not going to be able to use the dual intercept completely. I'm going to have to actually go ahead now and do what? Use my calculator. Okay, use the table method to sketch my function. So what you do then when you are using the table method, you simply have your x and y values. You choose some x values there at the top. Let's say maybe one x value that is negative. Maybe you choose -1, you choose 0, and you choose 1. You just choose those ones, -1, 0, and 1. And then you find your corresponding y values, and you sketch your function using these 1, 2, 3 points. Okay, because that will be enough for you to see the function, to see the entire function. I always suggest that for grade 10s, because grade 10s, your functions will always, your parabola functions are always symmetrical along the y-axis. Okay, all your parabolas in grade 10 are symmetrical along the y-axis. By that I mean, guys, your functions will always, they will always, this will be like your line of symmetry. Okay, well, so this y-axis is your line of symmetry. Your line of symmetry is always going to be the y-axis. So it's always going to be the line x is equal to 0 all the time for grade 10. So if you're a grade 10 learner, you are never going to expect your function to be symmetrical anywhere else but along the y-axis. So that's something that's very important for a grade 10 learner. Hence I'm saying, if ever you have a function, let's say you are given an opportunity to sketch a function, and let's say when you substitute 0 in the place of y, you are trying to use the dual intercept method, you substitute 0 in the place of y and you find that the function cannot be factorized. Don't stress, chill. All you need to do is just have a table, go and put in -1, 0 and 1 for x. Take the -1, substitute, get your corresponding y. Take the 0, substitute, get your corresponding y value. Take your 1, substitute, get your corresponding y value. And then you use these points to sketch your function. That's it. All right. I'm just going to do this one quickly. Let me show you through this example. Guys, this one, you can substitute 0 here. You won't be able to factorize this thing. It's unfactorizable. You won't get a solution for x because there are no x-intercepts. Are you with me? So what you do, and guys, you can do this for all functions in grade 10 for your parabola. If it's a parabola function, please guys, don't waste any time. Just draw a table, okay? And just use -1, 0, and 1. You could even use your calculator to basically formulate this, right? Just that guys, I've been giving away scientific calculators for years now. I feel like I don't own a scientific calculator anymore because my learners, I end up giving them away because they lose theirs and I end up giving away. And then I have to buy another one and I give away. Buy another one, give away. Okay? So I feel like I don't have any scientific calculator. So if you take -1, you substitute there. You substitute in brackets. -1 squared gives you +1. Then +1 plus 2 is a corresponding y value of 3. When you substitute -1, you get a corresponding y value of 3. You substitute 0 here. 0 squared plus 2, you get 2. Okay, you substitute 1 there, 1 squared plus 2, you get 3. All right, so our points that we have -1 and 3, we have 0 and 2, we have 1 and 3. And guys, these are enough points for you to sketch. Okay, thank you, Landy. I hear you what you're saying there. My Ubuntu is leading me to a state of having nothing. But it's fine. So -1. Let's go. Okay. So what I'm going to do here, I know this -1 I was speaking about, and this one is a negative. I started in -1 and this one that I have here. Obviously, I'm going to allow my sketch to go beyond those points. I'm not going to limit it to those points because basically, I'm just using those points so that I can see what's happening on this side of the graph, and I want to see what's happening on this side of the graph. And then y0 because I want to see what's happening on the y-intercept as well. So remember, when x is -1, what's y? So let's say 3 is here, y is 3 here. So when x is -1, y is 3. So where they meet is the point where it is. Does that make sense, guys? I'm repeating, when x is -1, y is +3. So where they meet is where my point is. Are you with me? So vertically -1 here, horizontally +3 for y there. So that's where we meet. We meet there. Okay. This is the place of meeting. Okay. So at least 3 and -1, they decided to go on a date, but they did not decide to meet at the places where they stay. They decided to go somewhere, somewhere, somewhere. So it makes sense, at least, you see, outside the home, which is key. Then the other point we have is where x is 1, y is 3. All right, so we can see, guys, where that is meeting as well. We are meeting here. All right, and then lastly, where x is 0. Remember, x is 0 everywhere on the y-axis. X is 0 everywhere on the y-axis. Everywhere, guys, on the y-axis. X is 0. But where is y equal to 2? So y is 2 is going to be somewhere here. Okay. Yeah. Then all we do, guys, we know that on the y-intercept, that's where the turning point is. So all I'm going to do is I'm going to exceed. You see? Do you see, guys, what's happening here? Do you see, people? Did you see? Do you see? So this is what you do when you cannot factorize. Okay? Okay, guys, I'm going to love and leave you after this because, like I said, yeah. Okay. Then you just mark the 2 there so that at least they can see the sketch. You see? So you can see the sketch. So that's just parabola grade 10. That's what's nice about grade 10. And you see, once again, your parabola, your y-axis is symmetrical. It's the line of symmetry. That's where the function is symmetrical. The other half is this side, the other half is this side. And it's cut along the y-axis. Okay? Okay, does that make sense? So, yeah, guys, simply use -1, 0, and 1. It's straightforward if you use -1, 0, and 1 so that you can just see. Now you see, -1 helps me see what's happening this side. +1 helps me see what's happening this side. And then obviously I need the turning point. Remember, for the turning point, you always let x be equal to 0. And obviously, whatever that value is, you are always going to be able to find when you let x be equal to 0. You're going to find your turning point. And our turning point, okay, is our 0 and 2. Okay. Okay, so I hope that makes sense, guys. And there it is. Bah! Inside the sketch. Okay, please make sure the points are marked because those are points that are a result of finding them. Your y-intercept 2 must be marked and labeled. Please, guys, 2 at least, clear, because that's where we are turning. And then those dots to indicate what's, those points where things are passing through. Okay. Okay. Yes, Leonardo, definitely. You are spot on. When you know my mind, because you spend too much time in my live session, so you know exactly my thinking process, my thought process. So now, if we were to write domain and range, I think my teacher, if she was still here, she would basically. Okay. Very quickly. If we were to write domain and range, let's come here. Remember, domain hasn't changed. It's still the possible x values where the function exists. So you are looking from left to right. Is there a place where the function won't exist? Remember, this parabola turning like this, it's going like this. It goes on, it goes on, it goes on. But look, this side, it goes on, it goes on, it goes on. So the function from left to right will exist everywhere because these arrows on either side. Okay? So that means the domain will be x is an element of real numbers for the parabola. But please be careful with the range. The range, remember, is the possible y values, and you are looking for at the function from the bottom to the top. So I'm sure you guys can see that here the function, it exists at -4 for y. Then it goes up all the way. Okay, but it does not exist below -4. So that means we can't say y is an element of real numbers, but rather, what can we say? Okay, from where? Remember, I said from the bottom to the top. So where you want to start is you want to start where? From the bottom to the top. Okay, so you can write your answer in either, you can say y is an element, you say closed from -4. Now, why are you closing -4? Why are you saying square bracket for -4? Okay, it's because -4 is included. The function does pass through -4. and you use your square brackets because you show that negative 4 is included as part of your answer. To where, guys? To positive infinity. Remember, infinity does not have closed, it has open bracket, because like I said, this is just a concept to indicate forever and ever, goes on, no stop. Yeah, so negative 4 to infinity. Or if you want to write it in inequality form, you can say y is greater than or equal to negative 4. This is another way of writing the very same answer. So you must decide, okay, because the function is above negative 4. This here means above or equal to negative 4. The function is above or equal to negative 4. Okay, so you must decide interval notation or the inequality form of writing the answer. You must decide. All right, so always when there's a minimum, it's always going to be y is greater than or equal to that minimum value. But remember, if it was a maximum, it would be y is less than or equal to that maximum value, if that was the case. Thank you so much for the rose, Miss Pearl. Really appreciate it. You're so kind. Okay, so very important, guys. Very, very important. Y is greater than or equal to negative 4 for this one. Let's come here. What would we say here is the domain? So once again, does the function exist everywhere from left to right? So yes, arrow to the left, arrow to the right. Does the function exist everywhere for x? Definitely does. X is an element of real numbers. Definitely does. Okay, then for the range, from the bottom to the top. From where? Which bottom? Okay, the y value at the bottom is, okay, let's see in the comment section. Let's see if you guys can tell me what the range of the function is. Let me not take away all your joy and your goodness. Let's see if we can't have any concave up, smiley face reactions coming up in the comment section there as well, together with your answer. What would you say is the range, guys? What's the range of the function? Guys, I guess people are sleeping. They're probably like, oh, I can't take this anymore. I'm sleepy. Yeah, I'm sleepy too. Y is an element 2 to infinity. I love it. What's that guy? I love it. Landile. Infinity to 2. Okay, remember, not that guy is 100%. From 2, y is an element. Okay, remember, we're starting from the bottom now. We there. Okay, don't mix it around. Okay, so we are saying y is an element of 2 to infinity. We can either write it this way, or we can say y is greater than or equal to 2. So y is an element of 2 to infinity, or you could say, if you don't want to write it that way, you could say y is greater than or equal to 2. Okay. Yeah. Please invites next time. All right. No, I hear you. I hear you. Okay. Guys, unfortunately or unfortunately, I'm going to have to end the live right there. I know there's a whole lot more, right? Like finding the equation of the parabola. No, small pizza, you can't say from negative infinity. Small pizza. You don't want to be a small pizza forever. You want to be a big pizza one day. Being a small pizza means you are not satisfying, and your answer is not satisfying me at the moment. So please, from 2 to infinity, from the bottom to the top, from the bottom to the top. The bottom, this is the minimum value. From the bottom, positive 2 to positive infinity. So there's nowhere where we are talking about negative infinity, where this is concerned. From 2 to infinity, or we can say y is greater than or equal to 2. For the domain, yes, we could say here, or x is an element of negative infinity to positive infinity, and then we say open brackets. We could do that for our domain. Okay, so grade 10s, thank you so much. I am going to have to love and leave you right now, unfortunately. So this is as much as I could at least cover in this live session. Yeah, this is ongoing. The battle to understanding functions is an important battle that we need to be able to wage and finally conquer. So if it does so happen that yeah, you guys are struggling, yeah, we'll work on it, and remember, we'll continue working on it even after you guys have written the test, because remember, what's important here is to understand the concept of like these functions, so that at the end of the day you can find ease in answering, and also like perceiving, you know, the relevance of functions in the grade 10 context, so that when you go on to the next constant context in grade 11 and 12, it's also a bit more forthcoming and your understanding is pashash. All right, thank you so much to all those that were here that actually really helped out a lot. Like Tori, so you are a star and a champ, buddy. Like no, you're like, yeah, my hat off to you, and many others that actually really helped, that were just here, not necessarily grade 10, but like just having the heart to be here and to sort of like give support, you know, in the comment section. Make this the comment section a, you know, yeah, a learning hub more than anything else, not just an aimless throwing of comments, you know, that can just distract and not add value to the concepts that we're trying to cover. So thank you a lot to those people that were here, you know. Yeah, thanks a lot. And thank you as well, guys, for just, yeah, the vibe. It was good. It was live. It was lovely. It was lovely. It was sweet. Yeah. New up on the list alert. I should be just going like this. Oh my goodness. That guy. What a guy. What a guy. He should know that in my TikTok live, I actually, maybe he's gonna call me up and be like, I'm his new up on the list alert. My goodness. Okay, guys, I don't have a fixed time, because like I said, I'm not really able to provide a fixed time of going live. It's really random, okay? Really random, and unfortunately I can't provide a schedule, because my schedule is not a schedule that is, like I said, that I can actually plan around, because of lack of flexibility and other commitments. So when I can go live, I do go live when I can help out, okay? Thank you guys. Have a good one. And catch a wake up, eh? Catch a wake up. Okay. All right. Cheers.